Hey, science class, we are in chapter 7 now. We're going to go through some examples of your chapter 7 homework. So this one, 7.1, starts off with what are the decisions that you can make when you perform a hypothesis test? There's only two, and they're all in this, okay? And both have to do with the null hypothesis. So when you go through and do your reading this week, you'll get this answer to this. There's only two things that we can do. The tests are about the null hypothesis. They're not about the alternate hypothesis. So the alternate hypothesis may seem more likely based on our data, but the results of the test are one of two things that have to do with the null hypothesis. So keep that in mind when you do question number 1. All right, question 3 and I think 4 maybe, these have to do with just understanding order symbols, because we need to know that for hypothesis testing. So order symbols greater than, less than, greater than or equal to, less than or equal to, not equal to, are all going to be important for this section. And complements in math mean everything except the things that are included in the first set. So like the even numbers are a set. The complement would be the odd numbers. It's everything that's not in the first set. All the numbers on the number line greater than 307 or equal to 307, we can include 307 in that because it's underlined, would be the numbers that are below that. So we're looking for two things. If I bring them together, I get back the entire population. So in this case, the numbers on the number line greater than or equal to 307 are completed. We can get the whole number line back if we include the numbers below 307. So that's the type of stuff that you're looking for on questions like that. Now, when we break up the number line into the stuff below a number and the stuff above a number like this, one of them will have to have equality. So greater than or equal to, strictly less than. The one that is strictly less than or possibly strictly greater than will always be the alternate hypothesis. And that is because we have to have equality in the null hypothesis. So when you're looking at this, null is the one with the little 0 below it, and the A is the alternate hypothesis. So we're looking for one that has strictly less than for HA and greater than or equal to for the H naught, or the null hypothesis. So strictly less than in the alternate, greater than or equal to in the null, that's F. So that's our answer of all those choices. Okay, so that's what we're looking for in these types of questions. Two things that complete the number line, and the one that's not, the order symbol that's not underlined in the alternate hypothesis. Okay, you're going to make sure that they stay the order that they are, and definitely don't flip around. We can't have a equality in the alternate hypothesis. We need the equality in the null. All right, this time we are not underlined, so the complement would be to flip the order symbol around and underline it. So flipping it around and underlining it is the complement. And now again, equality in the null, so P is greater than or equal to, and then less than in the alternate. So greater than or equal to, less than. There's our choice. All right, so same thing as the first one. It's just we're given the or equal to here, whereas here we're given strictly less than. All right, one of the big things that's important as we go through and we start to get deeper into chapter 7 is being able to translate the English language that we're given, the words, into a mathematical summary of that. So there I can see mean, so that's why I'm using the Greek letter mu here. That's the population mean. Is less than, right? So less than implies strictly less than, not or equal to. If it wanted me to include 9, like a less than or equal to symbol, it could say less than or equal to, or at most 9, something like that. But we need to be able to translate the words we're seeing into mathematical symbols. So mean, mu, less than 9. So mean, mu, less than 9. There's our answer. So we're just straight up translating when we see that question. All right, null and alternate, just like before. This is strictly less than, so that's the alternate hypothesis. The opposite of that would be greater than or equal to, would be my null. All right, the claim this time is the alternate hypothesis because it's strictly less than. So the claim this time is the alternate hypothesis. The mean is less than 9. So that would be F down there at the bottom. So that's what you're doing on a question like that. Translating it using what we've been talking about flipping the order sign around and either underlining it if it wasn't underlined or taking the underline away if it was, and then understanding, because that's what we see in the wording, that the alternate is the claim. All right, let's briefly talk about type 1 and type 2 error. I've got a visual here. This is a bell curve. This is the claim value of the population mean. Okay, now if I do some type of a test, don't worry about these numbers. The numbers aren't that meaningful. I just want you to see the visual. This is what we call the rejection region, the critical value. This critical value is where the numbers that are too far away begin. So I could fall in any of these regions that's not in the rejection region, and I'm not far enough away to say that the null hypothesis is probably false and the alternate is therefore true. But we have to understand that this is a sample, and when we sample, random things can happen. So again, I use this example, just something that people could relate to. Let's say it's salaries, and this is a claimed salary, average salary. If I did a sample and I happened to get like some kind of CEO for the company, it could pull the mean way up here to where I now fail to reject H0 and conclude this. But the average salary for the company truly is here. It's just because I got that CEO, sorry, the average salary truly is down here near the mean. But because I got that CEO, it got pulled way up because I had an outlier in the data set. And when that happens, it can really influence the value of the sample mean we've seen this semester. So it could be that it should have been down here, but because of just the sample that wasn't representative of the population, I ended up way up here. And because of that, I concluded that this is not true, that the mean is actually greater than the 52,994, when actually that was true. Right? That's what we mean by a type 1 error. It's due to sampling error or something unforeseen, something that we don't have control of. My sample ended up in the rejection region when it shouldn't have, and we rejected the null hypothesis when we shouldn't have. That's a type 1 error. All right, just to give you another visualization, let's do a left tail test. So there's a left tail test. Same thing, I could land here and not need to land there. That would also be a type 1 error. Now, a type 2 error is, this is actually true. The mean is actually less than the claimed mean. And I should fall down in there. I should fall down. So the company claims that their mean salary is $52,994. And the actual mean is well below that. So I should land in the rejection region and reject the null hypothesis. But again, because of maybe a poor sample, or just, again, I get that CEO in there, and I should be down here, but the CEO pulls me back out of that rejection region. Not necessarily all the way back to here, or even into the right tail, but just not far enough to reject it, just as long as I'm not in there. And so now I should be in there because the mean is actually far below that, but I don't fall in there. Right? And that's what we call a type 2 error. When this the null hypothesis is false, the alternate is then therefore true, and our sample does not have us reject the null hypothesis. It doesn't conclude the mean is less than. So that would be an example of a type 2 error. Okay, we can do that with a right tail test as well. I should fall in this region, but because of sampling or just something that I can't control, I don't fall in there. All right, and then we can have what we call a two-tailed test, which is the same thing. It's just we can fall above or below. So a type 1 error with a two-tailed test would be that this is true. The mean is actually equal, but I either fall too far above or too far below, and I reject it when it was true. Okay, that's type 1. Type 2 would be it's not true, so I should fall into one of the shaded regions, but because of sampling or whatever, I don't fall out into those tails. I stay in the non-shaded region when I do my statistics. Okay, so anyway, that is this visuals of type 1 and type 2 errors. So on this one, this says the percentage of household errors with more than one pet is less than 65%. That's less than, that's a left-tailed test. So a type 1 error would be, it's true that the null is true, so it's equal to 65%, but I fall into the rejection region. So I reject when it was true. So I conclude the claim that it's less than 65 when it wasn't less than 65. So the type 1 error here would be rejecting a true null hypothesis. So rejecting the null hypothesis, that percent is with more than one pet is greater than or equal to, that's the complement of this, when it's actually true. So that's our type 1 error. All right, type 2 error would be, again, the other way around. We fail to reject, so that's rejecting. We fail to reject the null hypothesis when it was actually false. Right? That's the type 2 error. Okay, so type 1 is rejecting a true one. Type 2, a true null hypothesis. Type 2 is failing to reject a false null hypothesis.